Hello everyone. Welcome to IIT-JAM in Chemistry tutorial number 53, and this is lecture number 9 of the Physical Chemistry chapter Solid State. The subtopic of this lecture number 9 is close packing in metals and metal compounds. In the fourth part of lecture number 9, the crystal structures of fluorite and antifluorite are going to be discussed. Let's start with fluorite. The fluorite structure has been extracted from the structure of calcium fluoride CaF2, which is a face-centered cubic FCC crystal lattice where the cations have coordination number 8 and the anions have coordination number 4 to make it an 8:4 arrangement. So, CaF2, it is calcium fluoride, and the nickname of this calcium fluoride, which is available in the mineral, is fluorite. And the structure has been adopted from its name fluorite. Here, the calcium 2 plus ions, that is the bications, actually form the cation, and the fluoride ions form the anions. So, here in the crystal structure of calcium fluoride, that is fluorite, the calcium ions form the FCC lattice. So, let's have a look first. This is the FCC lattice where the blue colored plus ions means the calcium 2 plus cations. So, they are forming the FCC lattice, face-centered cubic lattice. Now, if you divide this face-centered cube into 8 small cubelets, then each small cubelet will be equivalent to a tetrahedral hole because its body center is maybe surrounded by 4 cations. And this is what exactly happens in case of CaF2. Here, in the all the tetrahedral voids or tetrahedral holes are occupied by the fluoride ions. So, here in 8 small cubelets, you have 8 small cubelets, and in the body center of each cublet there is one fluoride ion. So each fluoride ion is tetrahedrally surrounded by 4 calcium 2 plus ions. Now on the other hand, each calcium ion is surrounded by how many fluoride ions? Look here, 1 2 3 4. Similar in the similar pattern in the above layer also there are 4 fluoride ions to make it 8. That means if you can say that fluoride ions are forming a simple cube and in the body center of the simple cube there is a calcium ion, then there may not be any kind of mistake. You will be right. So you can take it into account that each calcium ion is surrounded by 8 fluoride ions and each fluoride ion is surrounded by tetrahedrally surrounded by 4 calcium 2 plus ions. So the ratio of coordination number of the cation is to anion is cation has 8 and anion has 4. So it is a 8:4 arrangement. Okay. In the fluoride structure, the cations form the face-centered cubic lattice. So the cation is forming the face-centered cubic lattice and the anions are occupying all the tetrahedral voids. And what is the radius ratio? Radius ratio must be that of body centered cubic because the anions are forming the body simple cube and its body center, in the center of its body there is a cation. So the radius ratio must be 0.73 to 1.0. So it supports that the fluoride ions forming a simple cube and its body center, it is body center there situated a calcium 2 plus ion. Since there are 2 tetrahedral voids per each atom, it follows the Ma2 type of stoichiometry. Okay, let me discuss it from other angle. Suppose here the blue balls are the cations. So how many balls are visible here? Total 14. 5 plus 4 plus 5. Out of this 14, how many are inside the cube? You have already calculated this to be 4. 4 are inside and 10 are outside. So this unit cell is containing 4 cations. Now, how many anions are inside? You can easily count. All the anions are within the body of the unit cell. And it counts to be 8. So, for 4 calcium ions, there are 8 fluoride ions. So, the ratio is 4 calcium is to 8 fluoride. That is 1:2. That is metal cation is 1 and non-metal anion is 2. So, Ma2. Metal and anion. This type of stoichiometry is supported here. Okay. And since there are 4 calcium inside and 8 fluoride also inside, So you can easily conclude that there are four formula units within one unit cell. Okay, so there are four formula units within one unit cell. Now, here, as what I have said, this is the calcium ion. Okay, let me show you that each calcium is surrounded by 8 fluoride, and each fluoride is surrounded by 8 calcium with the help of some animation. So this is the small cubelet which is taken out, and in each alternate corner of this small cubelet, calcium ion is situated. So here is calcium in this vertex or apex. There is no calcium. Here is calcium. Here is no calcium. Here is calcium. Here is no calcium. Here is calcium. Here is no calcium. Here is calcium. So out of the 8 vertices, 4 are occupied alternately. Okay. So this is the picture of the small cubelet. Now, what happens in it in the body center of the small cubelet? The fluoride ion is occupying. Okay. So the coordination number of fluoride ion is 4. Now, as I have said, in the above layer, there are 4 more fluoride ions. So this is the picture of the above layer where 4 more fluoride ions are situated. Now let me separate this. Okay, look, this fluoride ion is surrounded by 8 number of this calcium ion is surrounded by 8 number of fluoride ions. Okay, and if you consider only the fluoride ions, then this is a simple cube. And if you consider both the fluoride ion and calcium ion, then this is a BCC lattice, body centered cubic lattice. Okay, so it depends in from what angle you are looking this. You're taking this into account. Okay, and not only calcium fluoride have fluoride structure, there are so many other compounds also. And apart from CF2, these compounds are uranium oxide, thorium oxide, cerium oxide, and zirconium oxide. Now there is yet another structure which is antifluorite. Antifluorite is just reverse structure of fluorite. That means in place of the cations, there are anions. The blue balls become anion instead of calcium cation. And in place of the anions, fluoride anions, they become cations. That means the stoichiometry was Ma2. Now the stoichiometry should be M2A, the reversed stoichiometry. That means the number of cations were 4 and anions were 8. So it was 1:2, that is Ma2. But now the picture has been reversed. That is the number of anions are 4 and number of cations are 8. So it is M2A. Let's see. When the anions from the face-centered cubic lattice, that means here the anions are all blue balls are forming the face-centered cubic lattice. And all the tetrahedral voids become occupied by the cations. So it has 8 small cubelets. That means it has equivalently 8 tetrahedral holes. And these are, if occupied by the cations, then this structure refers to the antifluorite structure. So antifluorite structure looks like this. So in that case, the stoichiometry becomes M2A instead of Ma2. So it had been in the fluoride structure Ma2. Now in the antifluoride structure, it's M2A. That is 2 metals and 1 anion. That is non-metallic anion. So this type of structure can be seen in lithium oxide and sodium oxide. So that's all about fluoride and antifluoride. Thank you and have a nice day.